Hi everybody. Today I'm going to be doing question 3.1 from the bingo homework. And this question is really asking two different things. It's asking first, part A is to find the components of the velocity, and then part B is finding the magnitude and the direction. So we'll start in part A, and what we're given are two different plots at two different points in time. So the first one is at t equals 0 seconds, and it's at 1.1 meter on the x and 3.4 meters on the y. And then the second time interval is at 3 seconds, and that one is at 5.3 meters on the x and negative 0.5 on the y. So to find the average velocity of the components, first we just pick one of the components. So I'll start with x. And the equation for the average velocity is going to be x2 minus x1 over t2 minus t1. And so all we do is we plug in the values from our two different data points. And so that'll equal, it'll be 5.3 minus 1.1 over 3 minus 0. And then those units are meters per second. So then if we just do that math, we end up with 4.2 over 3, which also equals 1.4 meters per second. So over here I'll just write the average for x equals 1.4 meters per second. So now we just do the exact same thing with the y. So we do y2 minus y1 over t2 minus t1. Or if you call that t0, whatever you want to do with that. So this is going to be v average y equals negative 0.5 minus 3.4 over 3 minus 0, which when you do the math out, it ends up equaling negative 1.3 meters per second. Oops. So these are the two average velocities of the components, and just like what we learned in class, the components are not vectors, they're just components, so we don't need to add the vector notation or anything like that to the components. So that finishes up part A. So now for part B, we need to find the magnitude and the direction. And so we'll start with magnitude, and that equation is the square root, so magnitude equals the square root of vx squared plus vy squared. And so now, since we've already done the two components, we just plug those values in. So that equals the square root of 1.4 squared plus a negative 1.3 squared. And then, so you just plug that into your calculator, you end up with 1.9 meters per second. So that's our magnitude of that vector. And then now we just need the direction, and then we're done. So the direction equation is theta equals the inverse tangent of v, so the velocity of y, over v of x. So just like with the magnitude that we did before, we just plug in the numbers that we've already found, which is easy. And so we end up with theta equals the inverse tangent of Vy, which we know is negative 1.3, over Vx, which is 1.4. So when we put that into our calculator and solve it, we end up with negative 42.9 degrees. So just to recap, what we've done is we took these two data points with different times and different locations within an XY coordinate system. We find the components of the average velocity, and then using those two components, we find the magnitude and also the angle, so the direction of that resulting vector. Thanks.